Hey guys, my name's DIOAN. I am the nerve monitoring technician here in the operating room at Massachusetts Eye and Ear Infirmary. Welcome. Today I'm going to be going over some relevant and important topics in regards to intraoperative neuromonitoring and how to use the NIM when dealing with or when monitoring during an Ansa to RLN reinnervation surgical procedure, a new technique of vagal electromyography when interpreting neural circuit status in children. So for our NIM accessories, you obviously can't monitor without a NIM console. This is the NIM console. This is what is important and integral to all of this because it is what is going to give us our visual display and audio feedback of EMG data. The second thing that we're interested in is our patient interface cable box that connects to the console and is sort of the middle man between the console and the patient. And the last thing that we need would be the muting cable, this lovely thing right here. This is what goes around electrosurgical instrumentation during monitoring to silence or mute artifact. So now we're going to go over the NIM accessories needed for our procedure. There are only two things that we need. The first things are a pair of hook wire electrodes, as you see here. They're color coded, so we're putting them in two channels in the electrode jacks. There's blue color coded ones and red color coded ones, which makes the pair. These are going into the patient bilaterally into the thyroarytenoid and posterior cricoarytenoid muscles. The next two things that come in the pack would be a ground electrode, green for ground, think of green for ground, and white, a white electrode, which is our stim return. You need this here because once you put in your stimulator, which is the second material we need, this is the actual stimulator that will be used when stimulating during monitoring. So the second material that we need is the stimulator. This is a PRAS standard monopolar stimulator probe, and that is, or it is what is going to be responsible when stimulating the nerve in real time during the surgery. So now we're going to go over advanced settings. Advanced settings are very important features when you are monitoring during your cases. And in this case, for an Ansa to RLN reinnervation surgical procedure, it is extremely important to have the right things to monitor. You can't go back and say, let's do that again. So here we're going to point out some really important features that are must-haves when doing so. This is our audio tab, and these are the settings. Very straightforward. The real one, or the real tab that we're most interested in and have to understand, is our monitoring tab. Here you have your monitoring tab. Again, this is the bread and butter of what intraoperative neuromonitoring is supposed to be when you are in cases. If you don't have the right settings or features put in place prior to the surgery, then you won't get the information or the EMG data that you're looking for. So, pretty straightforward. The things that I want to point out. Here you have your view scale. The first thing that I want to point out that's really important is your measurement cursor position. You have to understand that all NIMs are pre-programmed with their own advanced settings. And since this is a custom procedure, again, it's important to know that in this case, you need to have the latency chosen instead of peak amplitude. Latency is important here because latency is associated to time, or the speed in which an evoked response reaches the larynx when stimulating. It's measured in milliseconds, okay? The next thing I want to point out are your waveform filters. Normally, you have only your artifact filter chosen. In this case, you need to have both. An artifact filter is what will detect those spiked waveforms that you see, okay, that we know as artifact. Pretty straightforward. The low frequency filter, in this case, is important to have too, because it's also going to detect things like electrode, tissue, and movement associated with artifact. So that is also going to filter that out. The next thing I'd like to show you is event capture. Display transient event is not always a feature that we have when monitoring, but what display transient event is, in this case, is when the surgeon is stimulating. You can see the last stimulation that they had by having that display transient event on. Sometimes when they're stimming really, really fast, if you don't have this on, you can't capture it. If the surgeon says, hey, what was that last stimulation? You're not going to get it. So display transient event is just as important to make sure that you're getting all stimulation, if not the preceding stimulation before. The sequence display in which you're getting stimulations, the largest overall. We want the largest one to show overall, not the last. Again, latency obviously is extremely important here. It's showed up in two places. The reason why is because here, your measurement cursor position, it really is a place where when you're monitoring, where you can point anywhere on the screen where you measure specific points of the EMG waveform. Here, latency, we want to get the latency at the onset or the beginning of the EMG waveform. If I haven't said it before, we can't proceed with the case until we get a vagal response. That is why the latency feature is so important, because latency distinguishes between an RLN and a vagus response. There's a uniqueness about them that tells us that. The next part, or the last part really, is just your snapshot. You can have this comment box here. Sometimes when, and I'll show you on the main screen, but when you're stimulating and you want to get a snapshot of something, there will be a box that comes up where you can title it and put a comment there. So the last thing I want to go over is the stimulation. This is our third tab when monitoring. This is all straightforward. These are settings that we have, or these are the settings that we have. Everything looks great. The big thing here you want to have is that's checked off, that needs to be checked off, is reject stim pulse artifacts. Again, artifact is what is associated to the electronic noise when in stimulation. So again, all of this is to just really tone that down. You don't want to hear that during surgery. So now that we have gone over our advanced settings, you are now ready to get into monitoring action. This is our main monitoring screen mode, okay? This is what you are actually going to see in the main screen when you are monitoring. Most of you are familiar with this, but I just want to point out where everything is and what it means on the screen, in case some of you didn't know. Again, here we have our Stim 1. Here you can adjust the stimulation that's measured in milliamps. A lot of the time we keep it down to 1 for our Ansa to RLN reinnervation surgical procedure. We're not needing a Stim 2 in any of this because we are using just one stimulator. Stim 2 normally is used, this part right here, if we're doing APS or automatic periodic stimulation, where we are continuously monitoring a nerve in real time as opposed to intermittently stimulating. Here we're just intermittently stimulating a nerve to get that vagal response that we want. The events. We have our threshold set to 100. As you know, volitional speech is usually anything between 100 to 800 microvolts. And so we're keeping it here. This is a baseline threshold. The vagus response, or the response that we're looking for, if we get it, would be nice if it was over 500 microvolts. That is a start with the particular latency that I was talking about before. This is your volume, obviously. Your electrode check. The electrode check is really important here. Before you even go into the screen, you will get a screen that is your electrode check and status field. The electrode check is to make sure that everything is connected, okay? This is a shortcut here, but I will stress that electrode checks are important because it is what is being connected here in the patient interface cable box, but also what is then going to be plugged in or placed inside the patient. into, again, bilaterally into the thyroarytenoid and posterior cricoarytenoid. These are the channels here. Left thyroarytenoid to left posterior cricoarytenoid, right thyroarytenoid to right posterior cricoarytenoid. Okay, that is what that all means. When you do an electrode check, this is what's going to come up. Obviously, we're not in real time, but these X's will show up when something is not connected, okay? You will then get a check mark, a green check mark, when something is connected. This is important to know because if things are not checked, it becomes a troubleshooting problem in surgery. So you want to make sure that the electrode check, everything is green. Green is good. Just so you know, there is also, if you go here in more detail, there's actually a normal electrode impedance range for the kinds of electrodes that you're plugging in here, okay? This will tell you, X is no good, check marks, yes, green, go. So, another reason I'm mentioning electrode checks is because also, just because you have good connection intramuscularly with the electrodes, that does not mean that you have an intact neural working circuit, okay? And then the last thing I want to talk about is event capture, okay? Your best friends when you're monitoring are event capture and snapshot. In real time, when people are stimulating, or not people, when surgeons are stimulating the nerve, it's fast. So you have to stay with them. So your event capture and your snapshot are really important. When they stimulate the nerve, you want to catch the response. The event capture is going to capture that event, which is what really means that it is an evoked potential that has exceeded our threshold to then become an EMG waveform. You want this event capture because if you don't have it, you're not going to get that. The next thing that you have to have, this means you have just captured it. You have not taken a picture of it. That is what the snapshot button is for. Okay, this is that comment feature that I was talking about, but normally you would get your wave on your screen here, and then you could label it to whatever you wanted. Okay, so first event capture, then snapshot. You can also, let's just say that you don't have time to label something, okay? Another important facet is using the event capture to capture it. And then I like to use a feature called quick tags. These are pre-titled or labels that you can use. So when you do get the information that you're looking for, you captured it, and you can't hear it, but that is what's taking the picture. So that way you don't have to manually put in the title. The quick tag is already there to help you do it. So now that we have gone over our NIM accessories, materials, and advanced settings, you are now ready to go to work when intraoperatively neuromonitoring your pediatric patients. If you have questions, also make sure that you ask your Medtronic ENT reps. Thanks.